Good morning. I'm extremely happy to see so many faces in this room today. When I got the call to do it at 8:30, I was kind of worried. It's a bit of a nerdy topic, and it's an early time for a nerdy topic, but I'm very happy to see so many of you here. So today we will talk about models, requirements, code, and standards, and why it will matter for you at some point. My background is, I would say, enterprise mobility. So I have 10 years of writing codes for parcel delivery solutions with 100,000 devices in the field. So every bug you have will happen. And I would call myself a model-based software engineer. At the moment, my focus is more like the tool maker, building tools for people who do software development, not the real software projects anymore, but so I see many projects all over the world that make the move from traditional software development and systems development to model-based approaches. We are a small Austrian company, and we have lots of partnerships. I think most interesting in this context is that we also contribute to global standards like the Object Management Group or the INCOSI, that is the standards body for systems engineering, and we have lots of partnerships, mainly in the embedded space, but many of the concepts I will show you today are applicable or even required for line of business, apps, web development as well. So we will make a trip, and what you see here is not a real train, it's a model train. It's an abstraction of a train system, and it helps you to understand the complexity of a railway system. And this is exactly what the models are about. Models are about reducing complexity to have a higher level of abstraction of the software or systems you're gonna build. Now comes the obvious question. You know, if I do this on an automotive software engineering conference, I could skip this slide, you know. But because this is more like a general purpose software developer conference, this slide is very important. The embedded guys need models because they need an accurate documentation that is state of the art. Because if something happens with a safety critical device and somebody gets hurt, your ability to prove that your processes and your workflows and your way of developing solutions is state of the art makes a big difference when it comes to CURT. It might be the difference between going to jail or paying a fine or being just unguilty because you did everything possible. And this obviously applies for safety and security. In Germany, we only have one word for that, which is really, really stupid. It's just Sicherheit. One word for both. Not so good. So in Germany, you say funktionale Sicherheit or security. Safety, whatever. But why will this apply also to line of business or web applications? We have standards coming up about how you handle data of people. We have standards coming up how you handle credit card information. So if you have a cyber attack or you lose your data in another way, it will be again very important that you comply to these standards in your processes and that you have all the documentation in place and can prove that what you documented is really what you are running. This is really important, and many people don't think of it, but things are getting more and more critical, and the chance to go to court on one of these issues is raising and raising. It's not a nice reality, but it's a reality. And now a car example. Complexity in our cars is getting more and more and more. And this complexity leads to problems where entertainment interacts with safety critical. And this is a picture I took myself, and I was, you know, it's really nerdy, but I was so happy when I could take this picture. It's unbelievable. It shows an Audi, and we're just trying to park the car, and then there comes a traffic alert. And in this case, it's nicely implemented because the user gets a chance to decide if he wants to listen to the traffic alert or use the distance control. So this is a typical approach how you have to deal with safety. The park distance control is more important because if you run over a child but know where the traffic jam is, it won't help anybody. So this is the stuff why we need models in the automotive industry, because the systems are getting so complex every year. Who knows UML? Who doesn't like UML? I expected that. I can deal with it. So this is typically what you think of UML. It's an architecture, a class diagram, very similar to a database diagram. So I assume to some extent everybody of you is using models. If you use Hibernate, you're using models. If you're using database design tools, you're using models. But not UML models. It's a different type, but still you're using models. And these architectural diagrams are nice for documentation purposes. They help us developers to keep the overview. They help us to prove that our software is well documented. But the real value is just for the development department. There is no value for outside of the development department. So I feel if you do use modeling or UML or SysML, it's really key that you also care about the behavior. Because once you have behavioral charts like this, you get a chance to discuss the functions, the requirements with your domain experts. Because this is a language the domain expert will understand. If you show them C++, they won't. And we use this in the real world when we have new requirements in legacy systems. We show them our old diagrams and can say, okay, if you bring in this requirement, this is where we could put it, but this has this problem, this problem, this problem. We need additional requirements to fit the new functionality in there. And those diagrams are really, really helpful. Also, if you come to your old code 5 years later, 7 pattern evolvements later, those diagrams really help you in your daily work. The one is a state chart and the other is an activity diagram, but I guess you are aware of that. And yes, automotive is where I'm most familiar with, but we have similar standards now coming up for all types of stuff, for credit cards, for data about people. And the main thing that those standards force you to do is to have a proper documentation of the software you're running. And there is something called an audit, and if the audit comes, you have to prove to the auditor how you achieve this goal. And they will do some samples if you do it right. And if you can show them an automated tool chain that helps you do it, your audit will be pretty painless typically. At least this is the lesson that we learn from the safety critical software people. So UML is interesting. You know, use case diagrams, if you first see them, you think they are all just bullshit. It's the obvious, just drawn. But it gets interesting if you can do something like link your use cases with your requirements. And then maybe you can do a query, a report that shows that all your requirements, all your functional requirements are really linked to use cases. Because you might find requirements that you have not covered with use cases, or the other way around. Use cases where you have no requirements for. So models get interesting once you do linking traceability between various elements that you need. This is an example of a systems engineering model in the automotive industry. And here we used a different way of linking. The safety critical, the ASIL levels, are built into the diagram. And it's very simple. The red ones are the ones that we have to care about in terms of functional safety. And as I said, many people look at the modeling tools as diagramming tools, like Visio, like PowerPoint. But they are not. They are databases of net of graphs. And so if you want a valuable model, you really have to make sure to link the information and make it work for you and derive stuff from your models. Because this is one of the biggest failures we see when people try to start model-based software development or systems development is that they don't make sure that they really derive artifacts from the model that are critical for the definition of done. And if you don't make sure you get documents or configurations or code from your models, the first time you're in a rush, you will forget to update your model and the value decreases rapidly because your product and your model will be out of sync and you lost money basically. And as always in our application lifecycle world, it makes sense to do integrations. In my case, Rational Doors is a requirements tool that is not very loved, but it's a reality. And if you bring in requirements from your requirements management tool, even if it's Word or Excel, which is very popular apparently, you get extra value. And you need to automate all of this stuff. No copy and paste allowed, because it will really help you to get things done. And as you can see here, work products, this is really what I meant before, that you take your model repository and derive real things that you need for your product from the model. So, as I said, the diagrams are just a few, which means we can also have views on our model that look like a traceability matrix. Many people have to do traceability matrices with Excel, and they get very, very messy and huge, because it's Excel. And I told you we will look at C++, and this is one example where I have a traceability from an operation, a function, to a requirement in the model, and when I generate code, this comment is generated automatically. So I don't need a big document on my desk or on the second screen and update the IDs by hand. But once they are done in the model, they will always be there. I can report on them, and I can make things happen. I told you it's really important to generate stuff from the models. There is people that don't want to generate code. There might be reasons, there might not be reasons, but as this is a developer conference, I decided to to focus now a little bit on the code generation side of things. What are the inspirations for code generation? One is missing, that is to protect your assets from platform-specific implementations. Or that you can, if you generate code, you can make sure that people stick to the patterns and you have a nice architecture all the way. One of the biggest, obviously, is that you have a higher level of abstraction that helps you to discuss stuff with your domain experts or with your testing people. Never underestimate the value these whole models have when you have to collaborate with your test department. And that the documentation equals the product, which is pretty nice, because who likes documenting? Okay, we have one hand up from approximately 200. So it makes sense, doesn't it, to have this confidence that because I did my engineering in the correct process, I can skip the documenting overhead. And this is now interesting. This is something from Liebe, one of our tools. We have the problem with generating code is that it's like the old days when we moved from assembler to C. We wrote C, could only debug in assembler. Not very nice, because you would fix issues in assembler. And it's again similar. If you generate code from UML and you can only debug on C, C++, C#, JavaScript, whatever, and you lose connection and you start breaking the model-based approach again, because it's really hard to find problems and fix them in the model if you can't debug on the model. A second nice feature for learning and understanding that our UI has is that you can click on a state and you see highlighted which code was generated from that state. And this is exactly the feedback that engineers need to change their way of work. And now we go to Visual Studio. So my graphics card needs a little second, typically. This is a very special feature. Okay. So before we go to Visual Studio, I show you Enterprise Architect. Enterprise Architect is from Spark Systems, is our preferred modeling tool we use. The guys also have a booth here if you want to look at the tool. And the first things you see here is a class diagram like the one we see before where there's little value. In this case where I generate code, there is already value in the class diagram because this use relationship here will generate the include statements in the C code. Or you can see I generated some behavior, namely a state machine, that will be used to generate the logic of my application. And you can even see that I use some C++ code. Maybe this is a little bit small. The Microsoft guys teach me Windows++. So you can see I can even type C++ code directly in the model. It's okay. Don't worry. It's much better than typing the code somewhere else. And the next step I want to show you is now I can generate code. And there will be code generated from the state machines, the activity diagrams, the class diagrams. It takes a little while.
While this is taking a little time, we have one question for you in the meantime.
Okay.
Gerhard Leitner asked, I think that model-based development is more difficult with agile development. Do you agree?
No, I don't.
Don't agree.
Absolutely not. I'm not the top expert. A friend of mine in Japan is the top expert on this topic. We believe that model-based development is very important for Agile because it's the only way you can make sure you have a consistent professional documentation in the end. Okay. And we have a project where we use this and we use some methods to synchronize the activity diagrams that are built Agile with the code because we have a pattern to match them.
Okay. You have 10 more minutes.
Perfect.
Super. If there's any other questions, I have a microphone, or you can, if you've downloaded and installed the app, you can ask a question. I'm sorry, I say that sarcastically, but I have a microphone.
Okay. So here you can see some C++ code and an include statement and so on. And that was all generated from my source code. I can now build it. And hopefully it will build. Yes, it does. So I didn't do anything wrong. But we said we are on a journey from requirements to code. So what I can do now is I have a second view where I introduced my class as well, just for reasons of making it easier. And I can now add 2 requirements to this and create a simple trace link from my class to this requirement, which means I created this class because of those 2 requirements. That's the meaning of it. And because it's just one view on the graph of the model behind the things, I also have the second view, which is the relationship matrix, which will show me 2 little arrows that do the same thing. You know, they show me, okay, there is a trace relationship, and that's the type of thing many people would generate in Excel by hand. And now if we generate code again, the code is regenerated, and if the television cook prepared everything properly, what should we expect now? Of course, 2 new comments in our Visual Studio solution. And as you can see, they are here. And this way, it's really easy to prove to an auditor that the comments in your model make sense. And you can do that, this type of things for various stuff, for hazard issues, for some credit card checks or tests. You can even document test cases in code. And this way really gives you confidence that you have a full traceability from code to the requirements and the other way around. The next thing I want to show you is debugging. I connect my alternative visualization for the Visual Studio Debugger to the debugger, and I start my little software. It's a pretty simple game. It's a high-low. And I get a text displayed. I can type in something meaningful like 50, and I get an answer. And what I can do next, I can come to the model and go to the state machine.
You have another question from Raphael Schindler. Raphael Schindler asks, do you generate the UI?
We have projects where we generate UI as well. But typically we feel that most users will use special UI generators, but we obviously can import stuff into Enterprise Architect or other modeling tools, so you can keep the traceability up with the UI.
And what are the limits to that?
The effort you put into the tool making, basically. So now I can do something really cool, or at least I think it's pretty cool. I can set the breakpoint at on a state machine. And you can see the red dot down here. And now we will continue playing the game. And we will type in a low guess, so 1. Oh, I did something not as I wanted.
There's another question in between.
Okay.
Matt Bauer asks, do you think model-based development increases your hesitance to change the code?
No, I don't think so. It may change your hesitance to change the pattern of software development whenever you drank a strong cup of coffee. It will make your code more consistent. So somehow this is not what I expected. Anyway, I can also hit break here, and I will break into the code from the model-based debugging tool. And this is really the ways you need to understand and work with code and model-based stuff hand in hand. I can click now on a transition, and I can see exactly the code that was generated from this transition. And this is a very nice way to get going with code generation, because many of the tools are really poor. In Hibernate, it's really hard. If you do something wrong and the code doesn't look like what you wanted, it's not so easy to find out what you did wrong.
Then there was a follow-up question to what you just explained. 1 second. The Bernd Bergler asked, can you edit the model form code?
Yes and no. You can edit the code that is inside operations. We have special markers.
For instance, can you create the trace relation from a comment?
Not without custom development.
Okay.
Technically, yes. In theory, what we learn from the people that work with X-rays, and we learn a lot from the people with X-rays, because they produce very safety-critical products, and they cannot test with flash. The first time a person is treated is the first time they really test with some living people below the X-ray. And they completely stop this. They say, yes, we use code generation forward only for the parts we want to code generate, but it's perfectly fine to have handwritten code side by side. This is maybe an important point I forgot to make, that just because we generate code, it doesn't mean we have to rebuild everything. Stuff that works great or is easier or very mathematical can be perfect to write by hand. but for the logical parts, for the application logic, it makes perfect sense to generate code. I will try one more time my demo that I play and I hit the breakpoint in the model. I think I hit the breakpoint.
Gernot Egger had asked, how do you do code merging with visual models?
You can reverse engineer existing code, and then you can link the new code that you use for model generation together with the old code that you imported into the modeling software.
Okay. You have 3 minutes.
Perfect.
Sure.
So this is the highlight of my show. I made a breakpoint on a state, and it breaks in our UI, and I can see the same breakpoint in Visual Studio side by side. This is the tool we developed to make model-based code generation easier to understand and easier to work. Thank you for your attention. We have 2 more minutes, I guess, now. I'm very happy to answer any questions.
Thank you very much, Daniel Siegl. I think we were all kind of, half an hour ago, we were a little more sleepier. And one of the things we were talking about is, one of the things I noticed, people were looking for code in this conference. And this seemed to be a little bit more up the alley for many people. Again, if there are any questions, we have a minute or so. We have a microphone. Let's take one. And maybe we'll take one more. In the meantime, our next speaker
Hi.
can come
For
up.
the handwritten code, is there any restriction? Because C++ is not the safest language in the world, right?
Yes and no. C++ is not the safest language in the world, but if you look at the patterns the embedded guys use for C++, it gets a lot better. They use very restricted C++.
Last question?
For example, there's no mem-alloc in C for the embedded guys. Yeah, one question is here.
Where? Sorry. Last question.
Is your tool just available? Is your tool just available for Visual Studio, or do you have a?
No, we don't care about the EDA because we just generate C or C++ code. We have customers using it with Eclipse. We have customers using it with Kyle development environments, with Texas Instruments development environments. It doesn't matter for us. We just generate code, and we have connectors to some debuggers built in. We even can do real hardware breakpoints for those embedded guys. It's really interesting because nobody else can do that from models. And for example, at the moment we have Green Hills, Trace32, iSystem, Visual Studio, Lauterbach implemented in our standard tool. And via Visual Studio, we can even do GDB on remote Linux machines.
Good. Thank you very much. Daniel Siegl from Liebe.